Next up is topological sort. Topological sort basically works with a directed graph where it returns the nodes in an order. For example, if node A is pointing to node P, so node A will be printed first, then node B. So this algorithm is used to return the ordering of nodes in a list. Let's take an example. Here, if we have this graph, so we can see that node 1 is pointing to node 2 and node 3. Node 2 and node 3. So in my final answer, 1 will be printed before node 2 and node 3, whereas 2 will be printed before 4 and 5, and 3 will be printed before 4, and 4 will be printed before 5. So it will look like this. So this is basically the ordering. Okay. So in topological sort, the answer is not limited to one. You can have many answers, but the ordering should be maintained. Okay, this is used for the questions where there's a sequence given. For example, the courses question where you're supposed to finish the prerequisite courses before the actual courses. In such questions, you can use topological ordering algorithm. So, before I go ahead, this algorithm does not work with cyclic graphs, because what happens in cyclic graphs, if for example 2, 5 and 4, instead of pointing here, it was a cycle, if it was like this and like this. So here what happens, 2 is coming before 5, okay, 5 is coming before 4 and 4 appears before 2, but 2 is appearing before 5 in this case, 5 is appearing before 2 in this case. In such scenarios, we can't find the order, hence it is not suitable for cyclic graphs, only for acyclic graphs. So for writing the code for topological sort, we have many algorithms, and I'll be talking about Kahn's algorithm, which uses the concept of Indegree. So what is Indegree? Indegree is the number of nodes that are incoming to a particular node. For example, the integrity of this node is 0 because there is no incoming node on this node. But for 2, it is 1. For 3 also it's 1. This is the meaning of incoming node. Then for 4, it is 2 because there are 2 nodes pointing to this node. So it's 2. And similarly, even 5 has 2 Indegree. So this is the concept of Indegree which we'll be using. First, we'll find the nodes which have 0 Indegree. If a node has 0 Indegree, that means that is the first node, because that will be pointing to the rest of the nodes. So for topological sort, the order of nodes which we need will start from the nodes which have no Indegree. 1 will be the first node, and then we will eliminate this node from the graph. Okay, and also we will reduce the incoming degree for the nodes to which it is pointing, because if we remove this node, then these two should not be present, right? So we'll make this 0 here. See, it's like node 1 is the first node of the graph which is pointing to 2 and 3. Now I remove 1 from the graph because I have already inserted 1 to the order, and now that's it. The job of this node is done. Now we won't encounter this node. We won't come back. So 1 is removed, and then if 1 is removed, then even these two arrows shouldn't be existing. So we remove these two arrows, which basically is the Indegree to 2 and 3. It is an incoming edge for 2 and 3. Hence we will reduce the Indegree of these nodes by 1. The Indegree of 4 and 5 remains the same because we can see these arrows pointing to it. Alright, so the next time, now this node is removed, we have 2, 3, 4, 5 left. Now we check nodes which have Indegree 0, which is 2 and 3. So either we can start from 2 or from 3. So we add 2 and eliminate this from the graph, which eliminates these two edges. Hence we reduce the Indegree of these nodes to which it was pointing by 1. These are removed. Next, we find the edges which have Indegree 0, which is only 3 in this case. So hence we write 3 here and we eliminate this node, by which I can reduce the Indegree of the next node it is pointing to. So now 4 and 5 are left where only 4 Indegree 0. So I add 4 to the answer, and then this node with this edge is eliminated. I'm left with 5 with Indegree 0, hence 5 is added. So now I hope you have understood how this concept is working of Indegree in order to find the topological sort of this graph. See, topological sort, you can take a real life example for you want to boil milk. So what you will do, you will take the packet of the milk, that is number 1. Then number 2, you will pour it into a vessel. Then number 3, you will put it on a stove. And number 4, you will switch on the gas stove. So this is the order of events for boiling the milk. So it's similar to topological sort. Here we are working with the order of the graph. So this graph starts from 1 and ends at 5, and all the nodes in the order of the graph are printed at the end. So the strategy which I use to show the working of the concept in the above example, these are the 3 steps. First is that we identify a node with no incoming edge, right? That is with 0 Indegree. Then we add the node with 0 Indegree to the ordering and we remove it from the graph. And then we repeat all these steps. Now let's see the code. So guys, here we have a directed graph. Indegrees is the dictionary used in the code to store the Indegree of each node, where node is my key and the number of Indegrees, that is the number of incoming edges, is my value. This is here. Then nodes with no incoming edges will store the nodes which have 0 Indegree, right? And then topological sorting is my final list which will store the topological sort of this graph. So let's start. Initially Indegree, here I will choose a node and then I will loop through the neighbors of the node and increment the Indegree of the neighbor by 1. As I had explained before, what we do is we select the node 1, then we check the neighbors which is 2 and 3. Now I will increment the Indegrees of these 2 nodes because this node is actually pointing to 2. So Indegree of 2 and 3 will be 1 now. Similarly, we choose node 2 then, and node 2 points to 3 and 4. So 3 Indegree is 2, whereas Indegree of 4 is 1. Then node 3 is pointing to 4 and 5. So Indegrees is increased. Now 4 does not point to any node and also 5 does not point to any node. So my Indegree dictionary is ready. Next, nodes with incoming edges. In this, I check all the nodes in my graph. If any node has Indegree 0, then I will add that node to this list. So first, here we see that only one has Indegree 0. So I'll add 1 here. If you solve other questions, it's not necessary that only one node is a starting node. The order, the topological sort can give many orders as the answer. So you can have multiple nodes with 0 Indegree as well. So here we start the loop until the nodes with incoming edges is not empty. We will keep on traversing the graph. So first we pop out the element from nodes with no incoming edges. So 1 is my current node and I add it to my topological order. That's what the steps were which I showed before, that when a node which has no Indegree, that is my starting node and I will add it to the order. And now I remove this node from the graph and I also want to remove these Indegrees to these nodes, right? So I will be decrementing the Indegrees of 2 and 3 by 1 now. Now we can't remove this node 1 from the diagraph because that is our input graph. Instead, we use this Indegree dictionary to keep track of the indegrees of the nodes. So when we add the node to the topological order, we will simply decrement the Indegree of the nodes which it is pointing to, 2 and 3. So we will use this strategy. So here for neighbor in diagram of 1, we will decrement the indegrees of 2 and 3. Then here after decrementing, now we can check that which is the next node that should come in the order. So we see that 2 has Indegree 0. So we add 2 to this list. Now 2 is added to no nodes with incoming edges. So we pop this node, that is 2, and we add it to the topological order. Then we check for the neighbors of 2, which is 3 and 4. So indegrees of 3 and 4 are now reduced by 1. This and here becomes 1. So now we check the node with 0 Indegree, which is 3. And hence it is added to the list no nodes with incoming edges. Now I pop 3 and my current node is 3. This is added to the topological order, and we reduce the indegrees of neighbors of 3, which is 4 and 5, by 1. Okay, so now the indegrees of 4 and 5 both are 0. So we add 4 and 5 to my list. Now we pop the element 5 from the list, and my node is 5 now, which is added to the order. Then I check for the neighbors of 5. 5 does not have any neighbors. So we go and pop the next element, which is 4. And I check the neighbors of 4, which is none. So 4 is added to the topological order. So I have this list, and here we have to evaluate this condition. This order is only correct if I have all the nodes. If the graph has 5 nodes and my topological order also has 5 nodes, then only it is correct. If in case we encounter a cyclic graph or a cycle in a graph somewhere, check the condition. If the length of the topological order is equal to the length of the diagram, then we can return the topological order. Otherwise, the topological order does not exist. So this is the order for the graph. The graph can have other order as well. We can start from 1, and in the end where I had both 4 and 5 with Indegree 0, here the order can have 1, 2, 3, 5, 4 or 1, 2, 3, 4, 5. So a graph can have many topological orders depending on the number of incoming edges. So next, after the code, we evaluate the time and space complexity. So the time complexity will be big O of E plus V, because we are going to traverse all the edges and vertices of the graph. The space complexity will be big O of vertices V, because in indegrees we are going to use the space for n nodes, that is vertices. The same for the maximum size of this list can be the number of vertices and the topological sort. So altogether the space complexity is big O of V. You can see that this is same as DFS, time complexity and space complexity, and also BFS. So this was Kahn's algorithm, which is one of the algorithms for implementing topological sort in order to get the linear ordering of vertices in a directed graph. So if in an interview or in a competitive programming contest, if you encounter a question which wants the order of the nodes in a graph, that can be framed in any way. It can be framed as a game or a puzzle. So you can always think this as one of the approaches to solve the problem. I hope you understood the concept behind topological sort and its code. So that's all guys. Thank you.